Good afternoon, my fabulous chemistry students. Video number 4, periodic table. Today we delve into metals and nonmetals. So what are the properties of metals and why are they important? Metals do have very specific properties that make them metal. A nonmetal is going to be missing one or more of those properties. So let's get right into it. We can key the periodic table for many things. The staircase, that is this piece here. I will do it in green. This is what we call the staircase. On your periodic table, it is bolded, okay? Everything to the left of that is a metal. So most of the periodic table is metal. There's a common question, 75% of the elements are metals. Left or below the staircase, except for hydrogen, is a metal. So that's all of this here, except for this guy. We'll get into in acids and bases that he can act like a metal or and a non-metal, so we'll get into that a little bit deeper later. All the metals are solid except for the one, mercury. We used to use them in the thermometers. That was that silvery metal that goes up and down the glass when the temperature changes. Is toxic, so we tried to stop using that as much. The red in the thermometers now is alcohol. So there's your Easter egg. When you come see me and say, Mr. Milks, I watched video 4, I'm going to say, ooh, hey, what's the stuff in the red thermometers? And you're going to be able to tell me now. Must have all 4 properties of a metal. Here they are. These are the vocabulary terms that you're going to need to know, and some of them are not easy. Malleable, ductile, luster, and conductors. I will go over them now as you write them. Malleable means I can hammer it flat. So think of a copper BB. If I hit it with a hammer, it's going to turn into a copper pancake. Ductile is the most difficult one, I promise. Ductile means I can draw into wire. And literally, you can see me pulling my hand away from my other hand and my fingers going from open to closed. It's just drawing it into wire. And we need copper wire especially, but we need metals to be turned into wire because that way when you flip the switch, the light turns on. There's wire inside the regular light bulbs. There's definitely wire that goes from the switch to the light in general, okay? This is another common one. The reason why electricity even works, the electrons are considered to be in a sea of mobile valence electrons in a metal. They are moving around very freely. Moving electrons, flow of electrons is the definition of electricity. Electrons do like to lose their electrons and become positive ions. So as you see in the upper right hand corner, the first possible oxidation state for pretty much every metal is a positive number. I like to think about them as like metals are parents that like to go to the grocery store and not keep track of their kids. Like they could be in the freezer section and the kids in the produce section or that kind of thing. They don't keep them real close. They just let them go wherever they want. And that's really how metals act and treat their electrons. Nonmetals, we're going to find, are basically opposite in every regard. They're going to be to the right or above the staircase. Most of them are gases and a few solids, except, of course, for the one liquid, beryllium. I'm sorry, bromine. Misspoke. Beryllium's Be. They are not malleable. They are brittle. That means they shatter easily. They lack luster, which is shine. Oh, I forgot luster, didn't I? On the previous page. Luster is shine, and then conductor means heat will pass through or electricity will pass through. So I'm very sorry I got talking and I missed those last 2 of the big vocab words on the back. But see, if you're listening, you'll find out that I came through. Lacking luster, it's dull. It's not shiny. Okay, we are non or poor conductors. That'd be the rubber around the outside of the wire that's conducting electricity. We want a non-conductor around it so I don't get electrocuted. Non-metals tend to like to gain electrons and form negative ions. You'll see just about everyone except for boron, the moron, is a minus oxidation number for all of our first oxidation numbers for the non-metals. They're going to have 1 or 0 properties of a non-metal. They may have 1, but they're not going to have all of them, that's for sure. The metalloids is kind of where we start to get a little bit confused, if we will. So these highlighted in purple are the metalloids. You'll find that the staircase goes like this. So we like to say the elements around the staircase except for aluminum, which we of course know is a metal. We've had aluminum cans. The ones on either side of the staircase are what's called metalloids. So they basically have two properties of a metal along the staircase, and so they're tough to categorize. Are they a metal? Are they a non-metal? The thing is they might be shiny, they might be um, conductors, but they're not all four. So they're kind of on the cusp, and you can see as as we go from very metallic to less metallic, as I get closer to the non-metals, there's got to be this area where I'm kind of transitioning between a metal and a non-metal. And so another trend in the good old periodic table. So that's it for the video. You guys have some questions to answer that you can, of course, answer now because you watched the video. And now, of course, you can tell me the difference between what's metallic and what is not metallic. Those four keywords, let's make sure we memorize all those and we can spit those out at will. We can also complete practice now, page 6, 7, 12, and 14. Best of luck. See you in the morning.